Bismillahirrahmanirrahim. Hello, my dear students. I hope you are enjoying well. I welcome you all in class of O-level mathematics. Our discussion is continue on probability and combined events. Today lecture is very helpful, and in this lecture we will discuss very important topics. The first one is information about playing cards, also called well-shuffled pack. Second one is also very important, addition laws of probability. The third one is mutually and non-mutually exclusive events. Almost every year, one or more two questions asked from these topics. So let us start from the first topic, playing cards. You have seen playing cards. There are total 52 cards. 52 cards. These 52 cards are divided into two colors. Half are red and half are black. It means there are 26 red and 26 black. Further, these 52 cards are divided into four suits, or you can say four categories. There are four suits. Also called categories. These four suits or categories are named as heart, diamond, spades, and club. If you divide 52 upon 4, it means there are 13 cards of heart, 13 cards of diamond, 13 cards of spades, and 13 cards of club. So each are 13. These heart and diamond cards are of red colors. These are 13 red, 13 diamond, also red, and the remaining two categories are of black color. These are of black color. These cards look something like as my drawing is not fair, so kindly ignore my drawing skill. Heart, this is like this. These are this is the symbol of heart card. Diamond, this is like as you can say a rhombus or a rectangle, so a square, sorry. Spades and clubs. Spade is like this, look like something as, and club is lastly look something as. So these are the symbols their display. 13's heart, each card will be displayed as by this symbol, by this image, you can say. Further, the card numbers are, the first card number is A, also called card of ace. Second is 2, 3, 4, up to some 9. The next cards are denoted by the letter K. K stands for king. J stand for Jack, and Q stand for coin. So these are the total card numbers in these 52 cards. The first card number is displayed by the letter A. The next one is 2, 3, 4, up to 9. Each of these cards are of 4 types. For example, if you observe, if you see playing cards, one of the king, is of heart, is of heart. One of the king is of diamond, like this. One of the king card is of spades. And the last one is king of club. Similarly, there are 4 cards for jack, 4 card for coin, and similarly 4 card for ace. For example, ace card for ace of heart. Ace of heart card is like this. These three, it means there are 4 kings. One king is of heart, one king is of club, one king is of spade, and one king is of diamond. So there are the 4 kings in this well shuffled pack. Similarly, there are the 4 jack, 4 coin cards. These total 12 cards are called face card, and these are also called picture card, because in these cards you will see there is a picture of king, jack, coin. So that's why these are also called face cards, or sometimes also called picture cards. Picture cards. So in out of total 52, there are 12 picture cards, or also called face cards. The last one is okay. This is the total information about well shuffled pack or playing cards. I repeat again, there are total 52 cards. These 52 cards are divided into 2 colors, red and black. So that's why there are 26 red and 26 black. These 52 cards are divided into 4 suits, also called categories or types: heart, diamond, spades, club. So total heart are 13, 13, 13, 13. Heart and diamond both are of red colors. Heart is denoted by this symbols, this notations, this image. Further total card numbers in playing cards are: the first is A, second is 2, 3, 4, up to 9. Next letter is K. K stand for king, J stand for jack, Q is queen. There are total 4 kings. One king is of club, one king is of heart, one king is of diamond, one king is of spades, one king is of club. Similarly, you can make the other cards: card of jack, jack of heart, jack of club, jack of spades, jack of club, diamond. So these total 12 cards are also called face cards or picture cards. Next, we discuss how can we define mutually exclusive and non-mutually exclusive events. Two events, two events, A and B, A and B are called mutually exclusive, if they cannot occur at the same time, at the same time, or you can write if they cannot occur together. Otherwise they are called non-mutually exclusive events. Non-mutually exclusive events. Non-mutually exclusive events. Meaning to say, if they can occur together, then they are called non-mutually exclusive. If they cannot occur together, then they are called mutually exclusive. We see some examples. Suppose my event A shows occurrence of head. This is occurrence of head on a single coin when we toss a single coin. And B shows occurrence of tail. So I ask, if you toss a coin, is it possible that at the same time head and tail appears? This is not possible. It means these two events A and B are mutually exclusive events because they cannot occur together, they cannot occur at the same time. Similarly, if A is an event that shows an odd number on a die, on a single die when you roll, and B shows even number on a single die. Is it possible when you roll a single die, then both of the events occur together, appear at the same time? No, this is not possible because A is an odd number and B is an even number. This is not possible that at the same time odd and even number occur. So again, here A and B are mutually exclusive. These are mutually exclusive. These are also mutually exclusive. Suppose I take third example. Let A shows prime number, occurrence of prime number on a single throw of a die, and B shows even number. Now A and B are non-mutually exclusive events because this is possible that when you throw a single die, both of the events occur at the same time. How? 2 is a prime number. 2 is a prime number and it is also an even number. So both of the qualities are in 2. 2 is prime as well as it is even number. So we can say that when you throw a die, both of the events can occur at the same time. When the face of die is 2, then you can say that this is a prime number. This is correct. If one student says this is an even number, then it is also correct. So we can say that these are non-mutually exclusive events because they occur at the same time. We take another example. For example, in this example, we take B is an odd number. Then there are the two numbers in a die, 3 and 5. Both are odd and both are prime. So in this case, A and B again are non-mutually exclusive events. Suppose we take some examples from playing cards. Suppose by A is occurrence of red card. A is occurrence of red card. We have to choose a card from a well shuffled pack, and A shows occurrence of red card and B shows occurrence of black card. Is it possible that at the same time a card has both color? It is of red as well as it is of black. This is not possible. So that's why we can say that A and B are mutually exclusive events here. because they cannot occur together. There is a no card which has both colors. Suppose my A is my A is card of king, card of king, and my B is card of diamond. Can these two events occur together? Yes, this is possible that when you pick a card, both of the qualities are present in your card, because there is a card that is card of king and it is also a card of diamond. So this card has both occurrence, quality of both events. It is card of king and it is as well as it is card of diamond. So I can say that these two events A and B are non-mutually exclusive events. So in simple words, if two events occur together, then they are non-mutually exclusive. If they cannot occur together, that are mutually exclusive. For example, your life and death. If A is life and B is death, then A and B both are mutually exclusive, because if you have a life, then death cannot occur, and if death occurs, then you have no life. So in this case, A and B, in case of death and life example, A and B both are mutually exclusive because they cannot occur at the same time. Next, we move towards the last topic, addition laws of probability. These addition laws, there are two laws of addition for probability, and these are related to mutually and non-mutually exclusive events. First of all, when we have to use addition law of probability, when you see we have to find probability of uh, this phrase. What is the probability of occurrence of A or B? When you see this word or, it means we will use addition law of probability, and symbolically this can be written as probability of A union B. Now this probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Simply this case will be used when the intersection of A and B exists. Intersection of A and B exist mean A and B have some common elements. It means this is the case for non-mutually exclusive events. Non-mutually exclusive events. It means this formula of union will be used when you see your both events A and B are non-mutually exclusive events. You have to just simply see whether A and B have some common properties, some common elements, then you will always use this formula. And in case when A and B both has no common elements, it means their intersection is empty. And in this case, when intersection is empty, this is the property of probability. The probability of empty set is always 0. Now the formula becomes probability of A plus probability of B. So in this case, probability of A union B is equal to probability of A plus probability of B when A and B have a disjoint. When A and B are disjoints, they have no common elements, they have no common properties. It means in this case, your A and B are mutually exclusive events. Mutually exclusive events. For example, we will properly start questions about addition law of probability in the next lecture. Just for your elaboration, I will give some example here. Suppose we discuss this example. We throw a die. What is the probability that the occurrence is a prime or an even number? The occurrence on a die is a prime number or an even number. So, which formula will be used here? For non-mutually exclusive events or mutually exclusive events? This is simple. If you cannot guess here, when we throw a die, the total outcomes are 6, 1, 2, 3, 4, 5, 6. A represent prime number. Now prime numbers are 2, 3, 5. B represent even number. There is the only single prime, that is even. So B is 2. Is there intersection exist? Yes. A intersection B is equal to 2. That is non-empty. This shows simply we will use above formula because intersection exists here. So formula says probability of A union B is equal to probability of A. How many numbers are in A? 3 out of 6 plus probability of B. How many numbers are in B? 1. 1 by 6 minus. How many numbers are there intersection? Only 1. Minus 1 by 6. So answer is 3 by 6. That is 1 by 2. Suppose we discuss one more example. We have to choose a card of king. We have to choose a card. What is the probability that the card is of king or diamond? Card is of king or diamond. Now you have to observe, is there any card which has both quality? It is card of king as well as it is card of diamond. Yes, there is a one card. So what is the probability? Probability of king. If K is king and D is for diamond, we have to find K union D. Probability of K union D. This can be open as probability of K plus probability of D minus probability of K intersection D. How many kings are? There are 4. Out of total 52. How many diamonds? There are 13 diamonds out of 52 minus. How many cards which are card of king as well as card of diamond? There is only single card. So 1 over out of 52. So your answer is 52. 4 plus 13 minus 1. This is 17 minus 1, 16 over 52. And finally 4 for the 16, 13 for the 12. So the required probability is 4 by 13. So inshallah in the next lecture we will discuss this topic, addition of probability, with more detail. If you find this lecture is helpful, kindly like, share and subscribe. See you in the next lecture. Take care. Allah Hafiz.